let's discuss about the basic processing unit in this session. The processing unit is the one which executes machine instructions and coordinates the activities of other units. This unit is generally called as instruction set processor or simply the processor. Today in this session, let's discuss about the internal structure of processor and how it performs the task of fetching, decoding and executing instructions of a program. We know to execute a program, the processor will be fetching one instruction at a time and performs the operation specified. So here the instructions are fetched from successive memory location until a branch or jump instruction is encountered. So the processor will keep track of the memory address locations from where the data has to be fetched. So now we will use a register called as a program counter, which will be holding the address of the next instruction to be fetched and executed. Once the instruction is fetched, it will be putting into the another register that we call it as instruction register. This instruction. So the content which are present in program counter, it will be loaded into instruction register. So the content what is present in PC, we will generally take it as an instruction and it will be loaded into instruction register. To fetch the next instruction, the program counter should be incremented by 4, because we know in 32-bit processing, the addressing what we are using, the memory locations what we are using, they all are increment of 4. That is why in the next step, that is the second step, the PC will be incremented by 4 so that we can fetch the next instruction which is present in that location. After these two steps, we can carry out the action specified by the instruction in the IR, that is in your instruction register. So these two steps what we have, the first and second step, they are called as fetch phase. That is fetching of the instruction. And the third step what you have, that is execution phase. Therefore, the instructions can be fetched and executed in 3 steps. The first two instruction what we have specified, that is fetching, and the third step is your execution. So this is the internal block diagram what we have, that is a single bus organization of the data path inside a processor. So here you already discussed, that is the function of program counter and instruction register. The program counter is used to hold the address of the next instruction to be fetched and executed, and after the instruction has been fetched, it will be loaded into instruction register. So we have used general purpose register to store the data, to store the intermediate results from R0 to Rn-1, and we have some temporary registers like Y, Z and temp that can be used to store the intermediate results. Next we have MAR and MDR, nothing but memory address register and memory data register. So the external memory bus what we are using, that can be getting connected to the internal bus, that is the data and the addresses what is present in the external memory bus, it can be connected to the internal bus through the help of MAR and MDR. So this MDR what we are using, it is bidirectional, nothing but the data can be loaded into MDR from external memory bus and internal memory bus too, whereas the data stored in MDR, it can be sent on external memory bus and internal memory bus. That is why this MDR is bidirectional. So that is MDR is nothing but memory data register, that is connecting the external memory bus data with the internal processor, that is with the help of MDR. If we are with respect to address lines, then the external address lines can be connected to the internal processor with the help of memory address register, nothing but MAR. Next we have ALU, that is arithmetic and logical unit. So arithmetic instructions and the logical instruction, whatever we are having, all this will be performed by your ALU. You can see here we have addition, subtraction, and we have the logical instructions like XOR, and NOT. So for this you will be having the ALU control lines, and if we are performing the addition, of course we need a carry in, that is what we have taken as carry in. For this ALU, the inputs are A and B we have taken. The B input is directly taken from your internal bus, whereas the input for A is the output of MUX, that is multiplexer. So this multiplexer, we know it will be working on the select lines. So based on the select lines, we can perform the different operations we have designed. So here for this MUX, we have taken directly constant 4, and one more input has been fed from the temporary register Y. Next we have the instruction decoder and control logic. So the control lines, what we have, the control lines of the memory bus are connected to the instruction decoder and control logic block. So this unit is responsible for issuing the signals that controls the operation of all the units inside the processor and for interacting with the memory bus. So also this instruction decoder and control logic unit is responsible for implementing the actions which are specified by the instructions which are loaded in the IR register, nothing but your instruction register. So the decoder generates the control signals which are needed to select the registers involved and direct the transfer of data. Therefore, the registers, the ALU and the interconnecting bus are collectively called as data path. Are collectively called as data path. That is what we have said in the beginning. That is, this is the diagram for single bus organization of the data path inside a processor. So here you can see we have the program counter which is used to hold the address of the next instruction. Once the instruction has been fetched, it will be loaded into IR. So we have the two register MAR and MDR that are used to connect your external memory data and address lines of the external bus with the to the internal processor bus. If you are connecting the external data bus, then it will be connected with the help of MDR. If it is external address lines, then it will be connected with the help of MAR. We have the general purpose registers R0 to Rn-1, which can be used to hold to store your data, to store your intermediate results. Next we have the temporary registers like Y, Z and temp, which are used to store the intermediate results. Then we have ALU, that is arithmetic and logical unit, to perform the various arithmetic instructions and logical instructions. And we have used control lines too. Here one of the operand for this ALU is directly taken from processor, and for the other is it is taken the output of mux, where we will be giving the select lines so that we can perform the given operation. So here we are using constant 4 so that we can increment your program counter to the next location. So already we have written PC will be incremented by PC plus 4, because in 32-bit processing the address locations what we are using, they all are increment of 4. Next we have the control signals which are connected from the memory bus to your instruction decoder and control logic. So this is responsible for implementing the action specified by the instruction which are loaded in the IR register. Therefore, the registers, the ALU and the interconnecting bus are collectively referred to as the data path.